Okay, so today we're going to talk about Euler's number. Euler's a famous mathematician, Swiss, and he came up with something to do with compound interest. It's a formula that we used. Okay, so we have this formula: P times 1 plus R over N to the NT. P is the amount of money invested, or your principal. Okay, R is that percent rate as a decimal. T is the number of years. N is the number of times that you compound in a year. Okay. So it says, what would investing $1 change the formula to? So this dollar would be my P. Okay, so in that formula, it'd be 1 times 1 plus R over N, the NT. Okay, so that 1 is that P, our initial. Okay, but since it's just 1, we actually don't need it. It goes away. Okay, then it says, take the formula we just put in, and now we're going to change that rate to 100%. Okay, as a decimal, 100% we're changed to number 1, so R is 1. Okay, so it's going to be 1 plus our R, which is 1, over N to the NT. Okay, and what we're doing is we're coming up with Euler's formula right now. Okay, now we're going to restrict that T. Okay, restrict our T to 1 year. So we're going to take that formula we just came up with, the 1 plus 1 over N, and since T is 1, it's just going to be to the N power. Okay? So our final exponential equation is 1 plus 1 over N to the N. That is considered Euler's formula. We have a remaining variable of N. N, okay, it tells us at the top again, N was the number of times compounded in a year. So it's the number of times that it is compounded in a year. It's the number of times that it's compounded in a year. Okay, so now we're going to go ahead and start figuring out what Euler's number is using the formula. So our first one is when we compound it yearly. Okay, so when we compound it yearly, put in 1 for N, so 1 plus 1 over 1. Well, 1 over 1 is just 1, so 1 plus 1 is 2, and N again is 1, so 2 to the first is 2. Okay, so we're going to do 2 squared. So 1 plus 1 half is 1.5, and 1.5 to the second is going to be 2.25. I'm going to do it quarterly. So 1 plus 1/4, which is 0.25. So 1.25 to the 4th power is going to be 2.4414. So we're getting bigger and bigger, but it's starting to slowly slow down. Okay, now we're going to do monthly. So we're going to do 1 over 12 first. So 1 divided by 12 is 0.088. Add 1 to it. So 1 divided by 12 plus the 1 is 1.0833, and then to the 12th power is going to be 2.6130 roughly. Okay, then we're going to do it weekly, so 52, so 1 divided by 52. Okay, then we're going to add 1 to it. Then we're going to raise that to the 52nd power. That gives me 2.6926. We're going to do 4 decimal places. So you can see it's slowly slowing down here. So now we're going to do 365. So 1 divided by 365. Add 1 to it. But to the 365th power with 2.7146. Okay, then we're going to do 8,760. And we had 2.7183. Okay, then we're going to do every minute, which is 525,600. So 1 divided by that. Add 1 to it. And raise it to the 525,600 power. 2.7183. 3. I'm going to do it again, this time for every second. Usually 2.7183. Okay? So it says, what number is the function getting approaching as n gets larger? So it's going to be 2.7183. Notice the last 3 here, they were all the same, so that's the number we're approaching. This number is called Euler's number. We refer to it as E. Okay, that's the E on your calculator that you might see. Euler's number is considered irrational because it's not a repeating decimal. Okay, it's similar to pi. It goes on, but it does not repeat. Okay, we can use a calculator to make estimations with Euler's number. So let's go ahead and do that. So in my calculator, it says round to the nearest tenth. So it says e to the 7th. So in my calculator, I would do 7, and then there's a button that says e to the x. You would click that, and it gives you 1096.63, so 1096.6. And this is all calculator work. So now we're going to do negative 5.6, e to the x, negative 0.0037, but it says round to the nearest tenth. So what I need to do is I need to remove this decimal place there. And when I do that, I need to write it as 10 to the negative third. This negative here is the amount of decimal places that you are writing. Alright, e to the 0 is just 1, because anything to the 0 power is 1. E to the negative second, again, type in negative 1.2, and then hit e to the x, and get 0.3. Okay? Euler's number is a real number. Okay? And it's irrational. It's always a real number that's irrational. Okay? The domain for Euler's number is always from negative infinity to infinity. It goes on and on in both directions along the x. Okay? The range is when it's bigger than 0, 0 to infinity.